I'm here with Dr. Romano to do a problem on thermochemistry. We're going to do a tough problem on Hess's law.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the founder of OrgoMan and the author of the DAT Destroyer books. I want to do a question with you today on Hess's law, which is by far the most challenging question on thermochemistry. We got about 3 or 4 of these good questions on the Destroyer book, but I want to do 1 or 2 live with you so you can see the mechanics and how I do it. So come around, let's have a look. What I do is I gave you 2 reactions. And in the first reaction of hydrogen and fluorine to giving 2HF, I gave you the enthalpy, which is minus 542 kilojoules. And likewise, the forming of the water from 2H2 and O2 gave me a delta H of minus 572 kilojoules. I give you this overall equation, and what I want to do is I want to find out what would be the delta H of this overall equation from these 2 steps. The first thing I always do is I go to 1 step, I'll call 1 step A and 1 step B. If there was 3 steps, then I use a C. I'm going to now set up what I call my plan of attack. This is the way I teach my students over the past 30 years, and they always ace this topic. Now, the idea is if this is the mother equation, I call this the mother, and I call the little steps the babies. The name of the game is to make the babies resemble the mother. Now, what I do is anything that repeats itself, I cross out. So there's an H2 in the first step and an H2 in the second. Even if there's a coefficient, cross it out. Now, once I cross that out, means don't look at that. Now, in the first step, I can either look at this or this. Let's look at fluorine. In the mother equation, we want the fluorine to be on the left side. And it is on the left side, but we need a 2 in front of it. So my first plan is to keep reaction A, but times it by 2. Or if you looked at 2HF, you would have saw that HF is on the right side, which is correct, but you need a 4, so you would have times it by 2. So either way. Then you go to step B. Well, you can either look at this or this. Let's look at the oxygen. The oxygen is needed to be on the right side. Here it's on the left side, so what am I going to do? I'm going to reverse B. Now, let's do our little check of what we just did. What I did is I kept A, but times it by 2. So that becomes a 2, a 2, and a 4, which I wrote here. I'm going to reverse this reaction, and then once I do that, as you can see, these cancel out, and I'm now left with 2F2 on the left, plus 2 waters, gives 4HF, plus O2, so it gives you back the mother, so you know you did it correctly. Now you go back to your plan of attack, and you're going to keep A, so I'm going to keep the negative 542, but times it by 2, and I'm going to reverse B, so it's going to be plus 572, and when you add them up, you get negative 512 kilojoules. I hope you can see what I've just done. That's a guaranteed DAT question. Let's do 1 more. Now, what I'm going to do in this example is a little more challenging. There's now 3 reactions. 1, so let's label this is A, baby B, and baby C. And what I want to do is to calculate the delta H for this entire equation. So let's first cancel out all the things that are redundant. You have F's, don't worry about the coefficient, and then the C's, and then the H's are in more than 1 line, so they cancel out. Now, there's 2HF on the right side, but in the original equation, or the mother equation, we want a 4. So we're going to stay, we're on the correct side, but you need the coefficient 4, you already have a 2. So I'm going to keep A, but times it by 2. Then we go to B, CF4 is on the right side, here it's on the right side, but you need a 2 in front of it. So I'm going to keep B and times it by 2. And finally, C2H4 is on the right side, here it's on the left, I'm going to reverse C only. If you did that in the DAT, you don't have to check it. I think you should be comfortable enough, but always try to do a check and practice to build up some confidence. So let's go back. I'm going to keep A and times it by 2. So that becomes 2H2, 2F2 becomes 4F. I'm going to keep B and times it by 2 to give me 2C. there's 4F2 and 2CF4, and then I'm going to reverse letter C. Now, as you can see, 2H2 from here cancels, 2 C's cancel, and now what are we left with? We're left with C2H4, 2F2 and 4F2 gives me 6F2, and then you get 4HF plus 2CF4. Thank you, Lord. This balances out to the original equation, so you know you did it perfect. Now let's go back for the total. I'm going to keep A, keep the minus 540, and times it by 2. Then I'm going to keep B, which is the minus 680, and times that by 2, reverse C, so that becomes negative, add them up, and you get minus 2492 kilojoules. If you can do these two questions, and you can do the couple of questions that I got in the destroyer, you are set to go for the DAT. It's a little on the challenging side, but with a little practice, you'll be able to do these under 3 minutes. All right, I hope that helps. If you got any questions, I'll see you in the study group. Good day to you.